Okay, I hope that we get to this in class, but if not, I'm going to go ahead and make the video for this page as well. So, big day today is finding the derivative of polynomial function sine and cosine without having to use a definition. So, it says, consider the function f of x equals 3. What does the graph of this function look like? If the tangent line were drawn to any value of x, what would the slope of that line be? So, this is a constant function, right? If I graph the line f of x equals 3, think about what that would be. I would go to, oh, I should move that down. Stop it. I'll just start over. Over here. I would go up to 3 on the y-axis, and it would just be a line like this, right? So it's a horizontal line. So if a tangent line were drawn to that, what would the slope of that tangent line always be? Well, the slope of that line is always 0, right? So slope of tangent line will always be 0. So based on thinking about constant functions, any constant function, horizontal line, the derivative, the slope, is always going to be 0. And you could prove it with the definition, but I hope you trust me on that. Okay, so for the next ones, this is what I hope we get to in class, because I like to see your face when we do this, but we'll see if we got there. I'm going to give you the derivatives, okay? So these are 6 different functions, and I'm going to give you the derivatives. Not that I'm looking at my paper, but like I really can just do the derivatives just by looking at it. And I want you to see if you can figure out the rule that I'm using. So the derivative of the first one is 6x minus 2. And the derivative of the second one is negative 15x squared plus 4x minus 3. And so as I'm doing this, I want you to be thinking about what's happening. What am I doing on here? The next one is negative 9x squared plus 24x to the third. So think about what's happening with the numbers as I go along here, of how am I getting these without doing the limit definition. So now we're going to get a little trickier with some negative exponents and some fractional exponents. So what am I doing? Well, this one's going to be 2x to the negative 2 minus 6x to the negative 3. Do you have the rule yet? Hopefully you see what's happening with the exponents. As I take the derivative, the exponent goes down by 1 on each of the terms. What am I doing with those exponents? I'm multiplying. I'm taking the exponent and I'm multiplying it by the number in front. So that's why I got positive 2. And then I'm subtracting 1 from the exponent. On all of those, you can go through and see that. And the constants is 0, because we just said the derivative of a constant is 0. So that's why the derivative of all the constants are 0. So on this one, if I do that, what would that be? 4x to the negative 1/3 minus 8x to the negative 3, because 2/3 minus 1 is negative 1/3. And the last one, what would that be? 3x to the negative 3/2 plus 3/2 x to the negative 1/2. Okay? So this is a really important rule. It's called the power rule. Okay? So constant rules, this says the derivative of a constant function is 0. But the power rule says, based on what you've seen, you should now be able to infer what's happening. What do? When we have x to a power, we bring the power down front, and then we subtract 1 from the exponent. Okay, so maybe we should talk about this symbol here. D over dx, it means take the derivative. When we take the derivative, we have 2 ways of writing that, right? Well, actually, we have 3 ways of writing that. When we take the derivative, we could write it like this. We could write it as y prime. We could also write it as dy over dx. All three of those mean that is the derivative, but that means d over dx means take the derivative, okay? Okay, so really big deal. Maybe we got there in class, maybe we didn't. It says in order to apply the power rule, the equation must be written in polynomial form. What do you suppose polynomial form refers to? Well, it means that everything has to be worked out, because right now we only know how to take the derivative of each separate term. So it means, I don't know how to write that. Multiple terms that are just added or subtracted, right? So terms are added or subtracted. We can't do multiplication and division yet. There's a rule for that too, but we can't do that yet. So when you see these problems, they usually might have to be simplified first. So it says find the derivative of each of the following functions. Leave your answers with no negative or rational exponents as a single rational function when applicable. And so we'll kind of work on that too as we go through here. But the first thing I'll say, I'm not going to do all of these because I'm sure I'm already at 6 minutes. Okay. But like this one, I can't take the derivative of this yet because I can't do a fraction. So I have to think about how to move that to the top, which I could just write that as 2x to the negative 2 minus 4x to the third, right? So when I take the derivative of that, then I'm going to multiply the exponent down, so that becomes negative 4x, subtract 1 to the negative 3, minus 12x, because 3 times negative 4 is 12, and subtract 1. Now again, on a multiple choice question, you have to match the answer to the answer they have. On a free response question, you could leave it. And so that's why they say simplify if you can, just to remind yourself to simplify. So let's do a little simplification here. 1, we could write this as negative 4 over x to the third minus 12x squared. That would be no negative exponents, right? Now, if we wanted to write it as a single rational function, we would have to get a common denominator. Like, honestly, I would probably just leave it like this, but I want to do this one to show you the answer. If I was going to get a common denominator here, I would need an x to the third on the top and the bottom. So that would become negative 4 minus 12x to the fifth over x to the third. And that would be the simplified answer that they want you to give. But I really want you to practice the rules here, okay? Look at the second one. Again, I can't do division, but I can divide everything by x. So before I take the derivative, that's the same as saying 3x to the third minus 3x minus 2, because I just divided everything by x. Now, when I take the derivative, I need to show it's the derivative. So I'm going to say f prime of x equals, and I'm going to do the power rule. 3 times 3 is 9x squared, because I subtracted 1, minus, this one just has exponent of 1, so that's just 3. And if I subtract 1 from x, there's no x left. And then that's a constant. So look how quickly we were able to take that derivative. Let's look at some other ones. Like the next one. Well, what am I going to have to do first on that? I can't do multiplication right now, so I have to multiply it out. So this one I feel like I need a bigger box on, but I have to FOIL this out first, which would be x squared plus 3x plus 2x is plus 5x in the middle, and then plus 6. And then there's no shortcut to this. I have to just multiply by 2x plus 1. But the good news is when I get it down to a polynomial, I can just take the derivative. So I'm almost there. So that would be what? 2x to the third plus x squared plus 10x squared plus 5x plus 12x plus 6. And notice I'm labeling it. I'm not just putting equal signs, because is it f of x or is it f prime of x? We need to make sure we know that. And I like to cross these out because it helps me kind of keep everything straight. But I think that should be 11x squared plus 17x plus 6 And now I can do the power rule. So now I can say f prime of x, and I can take 3 times 2, which is 6, and subtract 1 from the exponent. 11 times 2 is 22, and subtract 1 from the exponent. 17 times 1 is 17, and the constant is 0. And look at that derivative, right? I want to jump around a little bit and do, like, you could do this one. It's going to be kind of like the first one. I want to do this one with this first and maybe a fraction. So 3x over the cube root of x squared. First of all, think about what that's saying. The cube root of x squared is x to the 2/3 because the root is the fraction. So step 1 on this is, remember, when we divide exponents, we subtract them. So if I was just simplifying this, 1 minus 2/3 is 1/3. And so now I'm just taking the derivative of that. 3 times 1/3 is 1. And if I subtract 1/3 minus 1, right, 1/3 minus 3/3, I get negative 2/3. And again, they want no negative exponents, no rational exponents, which means they want us to write it back like this. So I'm going to do 1 over, because it's a negative, negative goes in the bottom, and that's going to change back to the cube root of x squared would be the answer that they want you to give. What about the last one here? F of x equals negative 4x to the 3/4 plus 2x to the 1/4. Again, this one we actually can start, but then we're going to have to deal with simplifying it, right? So f prime of x, why does it just change colors all the time? Negative 4 times 3/4. And if you need to write it out, negative 4 times 3/4, the 4's cancel. So you get negative 3x. And 3/4 minus 1, you're not going to have a calculator to do this. So you have to think about, like, making it in the common denominator. 3/4 minus 4/4 is negative 1/4. And then 2 times 1/4 is just 1/2, right? And then 1/4 minus 4/4 is negative 3/4. Now, sometimes you can leave your answer like this, okay? But since we're practicing today, trying to review our exponent rules, think about trying to clean this up and what we could do here. It's kind of gross, but I could definitely move these to the bottom and say this is x to the 1/4 plus even the 1/2. The 2 can go on the bottom, and this would be x to the 3/4. So if I want to get a common denominator here, oh gosh, I need a 2 in both of them, and I need an x to the 3/4 because I can multiply to make this work. So my common denominator is going to be 2x to the 3/4. So what do I need over here? I definitely need a 2. And then I also need, remember, we add exponents when we multiply. So I need to multiply by x to the 2/4, which is really x to the 1/2. Right? So on the top there, 2 times negative 3 is negative 6, and I'm going to write that as x to the 1/2 instead of 2/4. And then over here, I already have the common denominator. So I don't do anything. It just stays a +1. And the directions also said not to leave rational exponents, so I'm going to change these back to radicals. So that would look like this. And that would be 2 times the 4th root of x to the 3rd. Again, just kind of to review some algebra, not that you're always going to have to do that. Okay? So we're going to practice some more. There's a whole thing on the next page about proving where the derivative and sine and cosine are. I'm going to put that video up, and it's going to be optional if you want to watch it. Mostly tomorrow in class, I'm just going to tell you what the derivatives are, and if you want to watch the video to see where it comes from, you can do that.